Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's Security Boulevard webinar, How to Give Everyone Access to Your Data and Still Keep It Safe, brought to you by Cyril. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, it will be available for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit securityboulevard.com/webinars, and it will be available for you as well. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. If you look at the handout section, you'll see 2 PDFs that have been made available for you to download and read at your own leisure, so check that out. And finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Rob Richardson, developer advocate, Cyril. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Welcome, everybody. We're going to talk about how to give everyone access to your data and still keep it safe. Wow, that sounds like that's not possible. Let's take a look and see if we can. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker, and it's never worked out really well for me. So let's go to robrich.org where we can find the slides there online right now. I'll head off to robrich.org. I'll click on presentations. And here's how to give everyone access to your data and still keep it safe. Here's the slides, and we're going to dig into those right now. While we're here on robrich.org, let's click on About Me and learn some of the things that I've done recently. I'm a Cyril developer advocate. If you're struggling with your data mesh, I would love to learn from you. I'm also a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp where you're connecting from, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, SQL source control basics, that was a lot of fun. Mine is chapter 8. That talks about how to do source control with databases. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into how to give everyone access to your data and keep it safe. We talked about this guy. So while we're in an audit, how do I document I've given the required permissions? Yeah, it's really easy to ask, but it's difficult to justify. Did I give them too much? Did I give them too little? And if I gave them too little, is there someone not able to get their job done? Now, what's interesting is we need to account for a couple of different scenarios where we're changing things. We're probably changing data store. We're mutating schema and maybe data access, adding new columns or new fields. We also need to account for changing users. We'll probably onboard new users. We need to clean up exiting users. We might have users that are transitioning into new roles, new departments, and we need to be able to ensure that as these users move, they have the permissions that they need, but they don't have excess permissions. Now, if you move between departments, it's really easy to accidentally continue having the old permissions as you move into your new role. So how do we do that? Now, as we're doing this, trying to give them just enough access, in the old times, we used to have this as a much kind of simpler system. We had a DBA department, and they were kind of in charge of all of the databases. We had a few databases, maybe we had a few BI tools, maybe we had some applications, sometimes we'd have some terminal command prompt things. And for the most part, we would ask the DBA department for access. They would give us content, and then we could move on. Now, we could wrap everything in a VPN that would allow us to secure our content just by kind of drawing that fence around everything. If you're on the VPN, then you probably have SSO credentials and access to shared drives, and now we can give you access to our data stores. As we transition to more of a cloud native experience, then we have a whole new model. We'll do cloud first deployments, where we're propping up data stores in public clouds or maybe private clouds. That means that we can't draw the VPN around it as easily. We'll have data moving to the edge where we definitely can't put the VPN around it. The beauty of moving data to the edge is that we can get it closer to where it's collected. We can get it processed there, perhaps even shared there, to the point that it doesn't need to move back to the central store. That means that those people who are really experts in that particular field are able to care for their data exactly where it lives. So we're moving away from the DBA department towards the DevOps department, where the DevOps teams are managing their own data stores. Now, this is great. That allows them to quickly evolve the schema. It allows them to use their domain expertise to really solve problems in elegant ways. But it also means that our data is out there. It's no longer here in our control where we can draw our neat fences around it. Now, we may choose to move ETL, move data to a data warehouse or a data mesh with ETL. And so now we have data moving in random places that it wasn't moving before. We now have a flurry of BI tools where we're even hooking up new tools that might also be cloud native. Now, this cloud native tool is connecting to the cloud native database. It never even passes through our networks. How do we control data in that scenario? As we move towards zero trust, we're moving away from that VPN and we're authenticating users based on their identity, not based on their location within our firewall. And that gets kind of complicated. So we tend to create service accounts. Now, I can create a service account to be able to let an application into place. That's wonderful. But now what if the users are using that service account to be able to get into the database as well? It's not uncommon if I just need to get something done that I'll pop open that web config file. I'll grab the credentials out of my package JSON file or the environment variables. I'll use that to quickly log in and get my job done. So how do we know that we've given those users the minimum needed permissions if they're not even using their own identity to connect to it? Yeah. In this new model, we have a flurry of policies and validation requirements. On the top, we have all kinds of different data stores. On the bottom, we have all different kinds of use cases, BI tools, applications. And so as we're connecting from these various tools into these various data stores, each one's going to come with their own flavor of policies. And that's where we're back to the service count. Can I just feed you this quick thing just to get my job done? Yeah, we have a lot of really fragmented policies across this data mesh because, well, they're all on the edge. They're all different kinds of data stores. And we really want that data at the edge where it's most useful. But we also want to be able to control access in a much more granular and holistic way. Securing the data. In the old world, we had a mechanism where we could carefully wrap this in a VPN, and this slow-moving data was able to get us to this goal faster. In the new world, we have two main challenges. Our data is moving faster. It's moving closer to the edge. It's moving outside of our control. And the business wants the data to move faster and evolve and change, distribute in interesting ways. When the business is pushing us into this direction, how do we still make that mechanism secure? How do we validate that we're only accessing the data that we're allowed to? The approval process. The approval process. Now, we've implemented this mechanism so that we can get an audit trail. Our goal is to have an audit trail so that when we're in the audit, we can pull up the audit trail and we can say, yep, see, I've done only the necessary things. So we needed an audit trail, therefore we have an approval process. Therefore, we need a content approval board, sometimes called a CAB. This content approval board is those executives, those senior leadership who understand the data stores deeply and understand who should and should not have access to it. A ticketing system. Now, oftentimes they'll work within a ticketing system so that we can pull up the tickets and we can say, on this date, this ticket was allowed to have this access. And on this date, that ticket was revoked and the user was no longer able to do it. So we built this content approval board and this ticketing system to be able to get through an approval process. But here's where it often happens. Now, I can tell you I worked for this company. I'm not going to name this company, but yes, it was this bad. So a user discovers they don't have access to something. Maybe they're a new employee and don't even know what access is necessary. So I get on Slack and I say, hey, how do I get access to this database? On Slack, the answer comes back really fast. You have to put in a help desk ticket. Okay, fine. So I'll go off to that formal system and I'll put in a ticket. Now, I don't know what department owns this data store. I only informally knew that the data store even existed. I don't know its schema. I don't know what fields I need, but I go file a ticket. So then I wait and I wait. Eventually, the ticket gets an answer and it says, hey, you've replied to the wrong department. Closed won't fix. Okay, what department do I need to submit a ticket to? Okay, so now I figured out what department I need to submit it to, and I submit a second ticket to the correct department. Okay, the ticket is routed to level 1 tech support. Now, here on level 1, all they can really do is consult their playbook, if there is one, to identify what they should do. Should I give them access? Should I get approvals first? What data is sensitive? What data isn't? And as our data moves into our data mesh distributed across things, it's quite common for them not even to have a playbook or a data catalog. Okay, so the tier 1 support in this case said, nope, you need an approval from your manager. How did I learn about this data store in the first place? Probably from my manager asking them, can I get access? So of course, they forward the ticket off to my manager, who rubber stamps it. We've had this conversation a dozen times where they keep asking me, have you done the job yet? And they forward it back into the queue. So now that the ticket is back in support and it has all the approvals that it needs, it goes in the queue to get approved by the approval board. Now, the approval board is made up of executives that meet quite infrequently. They're busy. And so maybe they meet once a month. In my case, it was once a quarter. And so now I need to wait maybe 30, 60, or 90 days for the content approval board to be able to take a look at my request. Okay, so the time has come. I've waited long enough. I'm now in front of the tribunal. And they take a look at my request and they ask additional questions. Now, I've definitely never seen the schema for this database. I don't even know if the data is going to help me answer my task. But I'm now before the tribunal here to justify my request. I don't know. So they ask some great questions that, yeah, probably I need to answer before I can get approved. And they reject my request. More information needed. Okay, so I go back to my manager, probably within the next, by the end of the day or maybe the next day. I've gotten the answers that I need, and now I'm ready to go back to the approval board. Well, the approval board meets once a quarter. So I am now in the queue again for 90 days, waiting for them to meet. So eventually they meet. Now they have enough information. Now they can give me their approval. And now begins the process of forwarding that ticket back to the support team to grant me access to that data store. Now, in that process, the business has moved on. That data is no longer valuable. I don't even know what data was there in the first place. But now that I have access to it, I come back to my manager and say, hey, I've got this. What question? And they're like, I don't know. We've moved on. Yeah, this approval process. What we end up doing is creating a culture where employees who don't have access just answer, I can't do that. I'm waiting for, let me put the blame on somewhere else. Or I'm not going to tell them that I still have access. As we move between departments, I don't want to go before the tribunal just to say, hey, can you revoke access to the things that I used to have access to, but I don't need anymore? No, I'm just going to leave it. And now I have access to too many things or not enough things. I can't get my job done. Yeah, that was painful. So why do we have the tribunal? Well, we have the tribunal so that we can enforce least privilege. Why do we have the ticketing system? We have the ticketing system so we can maintain the audit trail. The ticketing system documents who approved it, what date they approved it, the specific request, the specific grants that I was given. All of that is documented here in this audit trail. And because we have the tribunal validating it, we know that we're not going to set permissions incorrectly. But what we've got is this really contentious system that favors low productivity. In that scenario, I waited 6 or 8 months to be able to get access to data. Business can't wait 6 months for the answer to a question. That's just impractical. So what about unusual or infrequent tasks? Do we just grant them access forever? Or do they just answer, we can't get the job done? Maybe I need to run a month-end report, or maybe I need to do an ad hoc query into a data store that I usually don't have access to. I only need access for an hour. Am I going to go before the tribunal and wait 6 months to get an hour's access? No, because then if I need to run the report again next month, I'll need to go through the tribunal again. So probably we just give them access to this, even though they only need temporary access. Or the employee just comes in and says, I just can't do it. Yeah, that's our approval process. That's how we secure our data. And it's really unproductive. So we probably just default to using the shared service account. It was not infrequent in this company to open the web server, open the configuration file, go get the credentials that the web server is using to connect to the database, and use those to connect myself to the database. Now I can get the job done, and I have as much access as the application did, and so I can just get my job done. Now that's interesting, but we've lost all context of who accessed the data. Our premise with the service account is that it is narrowly focused to this one particular application, not that it's used broadly by the team. So maybe we create a second service account. This service account is specific to the application. We're going to lock you out of the production environment. And this service account is for your team to share so that now we can keep track of when people are accessing it versus machines. Well, that's better, I guess. We now have a little bit of separation. But how about those employees moving teams? When did we last rotate the service account keys? Never? That's not infrequent. So what about the people who have left the team, either to go to a different team or leaving the company altogether? Do they still have access to this data store? Well, our assumption was they didn't because they weren't inside the network. The VPN kept them out. But in a cloud-first, cloud-native scenario, there is no VPN. These are cloud-native resources, and they probably still have the keys using that shared service account. That's not great. Let's see what we can do. Let's take a cue from applications. Now, applications are really good at creating single sign-on type of experiences where I can authenticate to a known provider, and then I can come back into the application to do really elegant things. Applications store their content in source code. We store our source code in a Git repository. A GitHub allows us to have great audit trail history of what changed in our application. Anytime a change is made, we can automatically rebuild this application and publish its content. We have a great commit history that allows us to audit our system. And we have great communication mechanisms with pull requests and comments on the pull requests. This is a great way to build up an audit trail of an application. We have all of this history, this people process stored in our Git repository and in our GitHub communication system with the PRs. So could we leverage a similar mechanism? Here's that commit history where we can see exactly the date and time of every change. We can see who made it and what they did. We could even click into the particular commit and look at the exact code that changed. We also have pull requests where we can have great conversations around this content. We can either communicate on particular lines, or we can holistically describe mechanisms where things are moving in interesting ways. We also have automated bots that allow us to do interesting things. In this case, this build didn't succeed because there were some build failures that made that impossible. This ensures code quality and validates our system will work as expected. All of this is built into our applications. We have a great audit history through GitHub, and we have this excellent communication system. What if we could store our data access policies as code? Now that's really interesting. If we can store data access policies as code, maybe we can leverage those exact same mechanisms of communication and auditability that GitHub provides for source code. Let's take a look at what it would do to use policy as code. Now, in policy as code, we want standardized policies that are stored globally and apply to all databases equally. We need them to be both human readable and machine readable so that the humans can quickly parse them and validate that this is what we expect, and the machines can parse them to enforce these policies. At this point, we can easily audit the changes because we can just see when that code has changed. And maybe, if we trust our system, we can auto-approve those low-impact changes. No longer does the user need to go through the content advisory board. Maybe the user can get those things auto-approved asynchronously through GitHub approvals. Policy as code allows us to still have that auditability, that approval process, but not have the tribunal and all of the waiting. Now, part of the benefits of policy as code is we've simplified the onboarding and removal of employees. We can very quickly make code changes that'll make this happen, or if they're just part of SSO groups, we can apply these policies as code to SSO groups rather than specific users. We don't need to wander through our data mesh to collect the policies and data maps from all of the different systems distributed through our network and through the cloud resources that we've provisioned. We have a simple centralized policy as code that works across all of those data stores equally. We can remove the ceremony and pain from the approval process because GitHub gives us that natural mechanism to say an approval is required here, and once the approval is present, now we can proceed. And with policy as code, we can apply this uniformly to all of our data stores. Rather than just having that one policy over here and the one policy over there, if we've given someone access to, for example, email addresses, they'll be able to read email addresses in all the systems. And by comparison, if we don't give them access to email addresses, then they won't be able to read email addresses in any system. That's perfect. We've applied this policy universally to all the data stores. Now, what's really elegant about policies is they are standardized into records, readable by both the people who manage them and the systems that enforce them. That's really elegant. Policies as code works for both the machines and the people. The machines can enforce the policies, and the people can audit them really easily. We can then take that history of the code changes, the policy as code changes, and use that in our audits as we're trying to document that we've given people the minimum required permissions. Here's the date that it changed. Here's what changed. Here's the people that we gave access to it. Policies as code is a really elegant scenario for enforcing that mechanism of allowing our users access to the data so that they can accomplish the tasks while still keeping it safe. So our goal, let's lay out what we would like from policies as code. We want a simple approval process. We want global policies across distributed data stores. We would like to be able to use federated access using SSO groups. We'd like to give temporal access, so I can give someone temporary access to those resources that they need for only a short amount of time. And I want it to automatically build me an audit trail that I can use to pass audits. This is what I'd like in a system. Can we get there? Let's add Cyril. Cyril is a cloud-native federated access control system that supports consolidated policies and monitoring and real-time attack response. Now, today we're going to focus on the consolidated policies portion of it, but we'll also get to see federated access control. To understand more about real-time attack response, definitely hit us up at info@cyril.com, and we'd love to dig in more with that. Cyril Policies. With Cyril policies, we break these into two pieces. The data map that is database specific and enumerates the fields that we care about. This might be our data catalog. Now, we don't need to enumerate all of the fields in our database, but we will enumerate the fields that we want to secure specifically. Now, we'll give them generic names. Then we move over to policies where we can secure our content based on these generic names. So, for example, I can tag email addresses across all my data stores. Then I can create a single policy that will secure all of the content related to email addresses. A policy is generic name specific, tag specific, and applies that to the SSO groups that need access to that data. We can create access based on an SSO group, and we can create limits based on the number of records returned. So let's take a look at a policy. Here's a policy, and this is one that has all of the features turned on, but it allows us to really elegantly describe how we want to secure access to this data. Now, I've created a data map previously that identifies the fields in my various data stores, and I've enumerated them as age, email, and address. So this policy is going to secure all of the data labeled as age, email, and address. I've created my set of rules, and we can see that with each of these three rules, I've identified different identities that this applies to. In this first group, I've identified some network constraints and some service constraints, and I've identified that they can only read the address content and only 10 rows at a time. In this next group, I've identified a different SSO group, and I've given them different constraints. I'm going to mask the address and mask the age and only return one row at a time. With this identity, I'm tying it to specific users or specific groups, and I'm giving them access to all of the data, age, email, and address, and 50 rows max. Now we can see that we have a whole lot of opportunities to create these policies that can be as simple or as specific as we need them to be. And where we can specify most generic things in YAML, we can also dig into Rego to be able to codify other specific things that might dig into request details or connection parameters. So let's take a look at both data maps and policies inside of Cyril. I'm logged into my Cyril control plane, and I've got some, and let me wander into my data repos. Now, in this case, I have a customer's data repo. So let's go to the data map. And here in the customers section, I've identified those two fields that I want to secure. Now, there are more fields in this database than just email and name, but these are the ones that I'm worried about. So these are the ones that I'm going to secure. Now, I've given it a group name, a tag of sensitive. So now I can create a policy that will apply to all sensitive data across all data stores. Let's flip over to the policies, and we'll take a look at the sensitive fields. And here is that policy. For the sensitive data, I've said that the accounting department can read these up to 5 rows at a time. They can update up to 1 row at a time, and they can delete up to 1 row at a time. Now that very carefully identifies only this SSO group has access to those fields. Now, all the other data in those fields is accessible to anyone. I haven't identified them in my data map, but I definitely could. And I could also identify them as different types of data. So I created a database-specific data map, and I created a database-agnostic, data type-specific policy. Now, that was really cool. We got to take a look at our policies and data maps and how we can support data across all of our data stores. Now, already we've solved the distributed policies problem. We have data maps that are database specific that can apply to each database in our data mesh. And then we have one central policy that allows us to control access to the type of data that we want to secure in each data store. Now let's upgrade to policy as code. I've got this database. I've got this database right here and this customers database, and I've secured it previously with Cyril. So let's log into that database. Now I've identified the Cyril sidecar. I will log in with my username. In this case, I'm going to say from an identity provider, here's my email address. I want to log into the customer's database, and I'm going to grab my password. Now, the cool part, this password is built from SSO. I logged into this control plane using my Okta credentials. So here's my password that I'll use to log into the database. And we can see that straight away, I failed. I don't have access to this database. Now, recently in this organization, we reorged from an SRE and a developers department, and we created a new department. So we still have SRE and developers, but we now also have a DevOps department. And right now, the DevOps department doesn't have access to this database. Here in our policies, we very specifically said that only the accounting department has access to this data store. So let's see if we can onboard a new department. I've already created my group inside of Okta, and I've given this access to the application that we're going to use to authenticate. So here's the Cyril Ops application. All that Okta content is already secured. Let's now use GitOps, a policy as code, to be able to secure our content. I have here a GitHub repository that identifies those policies and data maps. So we saw the data map previously where we had the sensitive data, where we've enumerated the fields that we wanted to secure. And we saw previously how we have this policy that talks about which departments need access to this data. Now, right now, it's only the accounting department. Let's pop this open in VS Code, and let's modify this to include the DevOps department. So DevOps, I'll put that content in place there. And because this is a Git repository, Git status, I now have one change here. I'm going to git checkout feature / DevOps. And now in that new branch, I can start to commit this change. So we'll come here into source control. Let's take a look at that change. Yep, we've only modified that one line. I'm going to stage that line, and I'm going to say add DevOps to sensitive data. And let's commit that change. Now that we've got that change committed, let's push that up to GitHub and create a pull request. Git push origin feature / DevOps. Origin. Failed to push some refs. Did I fall off the internet? Nope. Git remote -v, git push origin feature / DevOps. I bet I am specifying this branch name incorrectly. Oh, git checkout -b feature / DevOps. I didn't get into this branch correctly. There we go. Git push origin feature / DevOps. Okay, now I've got this content pushed up to GitHub. And now let's flip over to GitHub and see if we can create a pull request. So immediately, as we open up here, we say, hey, we've got the opportunity to create a pull request. Let's do it. Okay, so I'll create this pull request, and we can see the files that changed. Yep, I only changed that one line. That's perfect. And let's create this pull request. Now, we can begin our conversation around this content. Here's one commit, and here's the files that changed. And so, of course, somebody's going to ask, should we also include SRE and developers groups? Because after all, that's why DevOps should get it, is we split the developer and SRE departments into 3 new departments. No, the comment comes back. No, let's do that as a separate commit. Sounds great. We've now resolved this concern, resolved conversation, and we've been able to have that great collaborative experience. Now, one of the things that we noticed here is that the Cyril Git bot has found an error in our YAML. This won't work as expected. So we definitely can't merge this pull request yet because we have some checks that are failing. Let's pop open our source code. Oh, yep, I forgot the dash here. There's the dash, and now we've got a policy that I think might validate in our source code. Good thing we had this change here, this bot here to be able to validate our source code. Fix typo. Let's commit that. And then I will git push origin main. Nope, not main. I will git push origin feature / DevOps. And now that I've modified that change, we can see that it immediately kicked off a new build. And now our policies our checks have passed. Now we could definitely set up reviewers here inside GitHub to be able to say, we can't merge until so many people approve it. We can even assign particular people that we'd like to approve it and link it to milestones or projects, other content to be able to organize it. And in this case, I'm going to approve it myself because I'm the one creating all the things. But now we're ready, and let's merge this pull request. Now, once we've merged this pull request, yes, let's delete that branch. Now back in our main branch, we can see that this policy now applies to both the accounting and the DevOps departments. Back inside Cyril, we can come back into our policies, and we can see that automatically that data is now in place in our Cyril control plane. It's now applying to both departments. Because we now have that policy applying to both departments, I can come back in here and I can log in. Let me go grab my access token, and I can log in to my database. Did I specify that incorrectly? Oh, I did miss one piece. Let's come into the data repo and assign the DevOps department access to this repo. I'm going to create an identity map, and I missed this part in my practice too. And I'm going to specify that this group, this DevOps group, can use the Postgres account for into my data store. Now that I have both the policy and the identity map in place, now I'll be able to log into my data store. Let me go grab my access token again, copy that, paste that right here, and I'm logged into this database. Now that I'm logged into this database, one of the features that we've identified in this policy is that I should only be able to read 5 rows at a time. So if I come into this database, and yeah, I just got access to this database, this is great. I'm going to come in here to the customers table. I'm going to select the data, and it has more than 5 rows in its database. So yes, of course, I'm blocked from getting access to those fields. So if I limit it not to 50 rows, but if I limit it to 3 rows, now we can see that we have access to that data. Here's the fields, and now this is the first time I've been able to see those fields: ID, account, name, email, country, active. Now, the only fields that we chose to secure are these fields specific to this, not there, name and email. So if I wanted to get access to other fields, let me create a SQL command. Let me select ID, account, and active from customers. Now, because we chose not to secure these columns, I'm able to see all the rows this way. But the moment that I choose to add name or email, then that's when I'm blocked until I specifically filter out by the limit. And in this case, I'll only ask for 3 rows. Perfect. we were able to onboard this new department into our Cyril control plane and be able to secure our customer database in our data mesh. Now let's look at another example. Let me log out here and I will git pull here. That will get me git checkout main, git pull. Now I've got the change that I made, I've got that fix, and I've got that merged back into place. So I can probably git branch -d feature DevOps. I don't need that branch anymore. Git removed prune origin. Let's delete that branch. And now let's look at this next scenario. And in this next scenario, we want to onboard a new data store into our application. Now, I've already created this data repository. I've created this products data repository, and I've already mapped the DevOps department into place. But I want to secure this with data maps and policies. Let's go back to GitHub and make that change. Now here in my data map, I want to identify a new repo. So I'm going to go grab this repo and I'm going to set it into place. This is the products database. And now the only field that I want to secure in the products database is this cost field. I don't need to secure any other details. Now, we've made a change in this data map to be able to onboard this new database, but we don't need to make any changes in our policy. This policy will apply universally to all of the data stores. Great. So let's come here into our source control, and we will add this, add products database to data map. Let's save this. And then we will git checkout -b feature /products, git push origin feature /products. And now that we've pushed this change into our database as a pull request, let's come back to GitHub and take a look at our database. Yep, we have the opportunity to create a new pull request. Let's definitely do that. So we've got a new data map, and we want to create a pull request for this content. We can definitely have conversations around this based on making edits in our commits. But in this case, I think it's good. I've got all the approvals, and so I'm going to merge this pull request. Once I've merged this pull request, we can see that we've already got the green light from the Cyril bot. Then immediately that content will be available here inside my data map. Yep, there's my new products repo. And so now I've got that products repo secured by this data map and policy. So let's log into that products repo. Now I'm going to use my same identity based on SSO. Let's go grab my password. So let's go grab my access token right here, and we'll go into the products database. Now that I'm logged into the products database, we can take a look at that content. And remember that policy that said I can only show 5 rows at a time? Well, we didn't need to modify that policy at all. That takes effect equally to this new database that we've just unloaded into our data mesh as the other policy did in our data mesh. That cost column is the only one that we wanted to secure. So that's the one that's allowing us to only see 5 rows at a time. Perfect. We were able to onboard a new department into our data mesh. We were also able to onboard a new database into our data mesh. And all of this content is available and easily auditable inside our GitHub repository that describes exactly what happened when it was merged and what approvals were necessary to get it in place. That's great. We were able to use GitOps to be able to create this policy as code and to be able to control our content coming into the Cyril dashboard. It's this process that's really elegant about getting content from our developers and our data professionals into our Cyril control plane. We'll create a commit that will get validated by the Cyril bot to validate that the syntax is correct. We create a pull request, and reviewers can now comment on that content, and we can adjust it until that policy is correct. Once the reviewer merges it, then that'll automatically get played into the Cyril control plane, and that becomes the new data definitions and the policies that apply to all data stores. Now that was really elegant. We used that same process that developers use to be able to get our policies as code into our data store. Excellent. Yes, we got global policies across our data mesh. We have this great audit trail for policies, and we got federated SSO access to our data stores. No longer are we using service accounts to be able to access our data stores. We know specifically which users are accessing our data stores. Now let's talk about temporary access. What if I only need access for an hour? Now I have this other database here inside my data store, and I have this sales database. Now this sales database is already hooked up, but we'll notice that we have no identity maps in place. So nobody has access to this. Taking a look at our data map, we can see that we have the sales, the customer ID secured here, and we have a policy here for the sales data that says that nobody has access to it. Perfect. Now I only need temporary access to it. I only need it for an hour. So let's come into Slack. And in the way that I requested access before in a very informal way, I'm going to come in here and I'm going to say, Cyril request. Okay, I've requested access, and now I'm going to choose the sales database. I'm going to choose which account that I want to use to log into, and I can choose the sensitive resources that I want. Now I'm going to get access to all the other fields as well, so I don't need to enumerate those, but this is the one sensitive field that I need access to. I need access to the customer ID. Now this star is a shortcut for accessing all of the other columns. In this case, I'll just pick the one that I want. How long do I need it for? I need 1 hour, and I need access to run the report. And you let me in. Now remember the content approval board where this would go into a queue, and 3 months later, 6 months later, we might get an answer? I'm going to request access. And immediately inside the Cyril ChatOps channel, those who have access to this channel and who are administrators over the system are allowed to approve or deny the request. Here's all the details, and I can audit this right here. In this case, I'm going to choose to approve this request. Yes. So let's come back to our store, our admin tool, and we will log into the sales database. So I want sales. And let's go grab my password. Here's my SSO access token. And I will log into the sales database. Username not found. Oh, because I didn't finish writing my username. Let me finish writing my username. And now I have access to the sales database. Now that's perfect. I now am able to get the job done that I need to. So I'm going to come into the sales table, and I'm going to select some data. And now I'm able to get my job done. Now, the moment that my job is done, I can either wait that hour that the duration was, or I can just message back to ChatOps and say, hey, I'm all done. And so then they can come in here and they can revoke access. Now, the moment that that access is revoked is the moment that I lose access to this system. Let me click select data again, and I'm automatically logged out. Perfect. We were able to grant them access for only that short window that they needed to be able to get their job done. We still have that audit history both here in Slack and in the Cyril control plane, and we're able to give them access to the data that they needed so that they can accomplish the job. Now, what if this was a low impact change? What if I didn't need access to any sensitive information? Okay, so let's come in here and let's request, I'll say Cyril request. Let's request some content without sensitive fields. Now, my account has been set up to allow automatic approvals if I don't ask for any sensitive resources. So I'm going to say I would like this for 1 hour, and I don't need sensitive data, and I will request access. Now, because I'm not accessing sensitive data and because my account has been configured to do so, I don't need any additional approvals, and this was automatically approved. Here in ChatOps, we can see that it was automatically approved. Perfect. So I'm going to come back in here and I'm going to log in again. Let's go grab my access token, select, and we will log in. Great. So now I've been able to get at this content. But now, since I wasn't given access to all of the things, the normal policy applies, and I need to limit my request to 3 rows. And now I can see this data. That's perfect. Because our policy enumerated that I was only limited to non-sensitive fields, then everything worked great. Here inside the Cyril console, we can see that in my sales repository, we granted access to this user for only an hour. It will expire automatically in 59 more minutes. Now that's perfect. Once I've accomplished my task, I can say, hey, I'm all done. We can revoke access. Immediately, the approvals are removed from this database, and I am no longer able to access this data store. We're able to do temporal authentication to only give access for those portions of time that we needed to, and in sometimes automatically approve it if there weren't sensitive resources involved. With the Slack bot, it's a really easy communication strategy to request access, for those in authority to grant access, and for me now to have that short window of opportunity to be able to get at the data that I need to accomplish the job that is before me. That is wonderful. We don't have to do that long approval process just to be able to get access to do something really simple. A quick chatbot, and we're able to get that. We still have the same audit history, both in Slack and in the Cyril control plane, to be able to walk into an audit confidently that we haven't given access without authority or without responsibility. Slackbot policy approvals. We get just-in-time access for privileged resources. We can automatically revoke when the time window closes. And we're still using an SSO identity to be able to validate to this data store. We're not using a shared service account, and we know exactly who is doing the task and for how long they have access. This automatically creates the audit trail so that we can confidently walk into an audit knowing that we've been able to secure our database correctly. Cyril is that cloud-native, consolidated policies and monitoring, federated and temporal authentication, and real-time attack response. If you need to be able to secure your data mesh, even as it's distributed across various places throughout your organization and throughout the cloud, you can use Cyril to create these data maps that are database specific and these policies that are global to all data stores to be able to ensure that you can secure your data in all of the places where it natively lives. This has been a lot of fun getting to show you both GitOps and ChatOps native within GitHub, within Cyril. It's been really fun getting to show you this content. If you have more questions, if you're watching this video later, hit me up on Twitter at Rob_Rich or at Cyril Inc. and let's continue the conversation. These slides are available right now on robrich.org, as is the GitHub repository that we used to be able to secure our code through policies. And for those who are here live at the event, what are your questions? What are your thoughts? What can we do to make this better apply to your implementation, your databases and security needs?
Okay, we do have a lot of questions. Unfortunately, we won't have time to get to to all of them, so we will follow up with you afterwards. First question here is, how do I set time limit for how long a user can request a Slack bot auto-approved query?
Great question. We kind of breezed over that a little bit, but as I was doing my request, I can request the amount of time that I need. Now, in this case, Cyril request. In this case, I can ask for how long I need. Now, how do I cap that so that they don't ask for forever? Here in the Cyril console, as I'm creating my data repository, let's come back into this sales database. And when we create these identity maps, actually, let's come into the customers database where we've configured this. Here in my identity maps, as I create a new identity map, I can specify the duration. Now, this says that this group is only allowed to access it for 1 hour, or I can give them unlimited access. And so in this sense, I can say, nope, this group is only allowed to auto approve at an hour or a week or a day. And if they ask for more, then they need a manual approval process. It's here in this duration section that I'm able to set that limit. Great question.
Excellent. Next question. Can I commit directly to the main branch, or must I create a pull request first?
Good question. In this case, we created pull requests because we were able to facilitate that communication. Now, based on the policies that you set inside GitHub, you can very specifically require that. I'm going to come into settings and I'm going to choose branches. And I can choose to secure my main branch. Let me create a branch protection rule. I'm going to say, no, you must create a pull request before you commit. And I'm going to require that the number of approvers is 1 before. And so to be able to merge into main, you have to follow these rules. I can configure them here in GitHub in the same way that I would configure them for any other source code repository. GitHub has great tools for being able to protect the main branch.
Excellent. Okay, I think we have time for one more question. What databases can I secure using Cyril? Wait, I think must they all be relational?
Good question. In this case, we're focusing on Postgres databases, but Cyril supports many different databases. We could say here in the data repos that we have MariaDB. We also have a MongoDB, an Oracle database. We also support SQL Server, S3, and others. It's really great. We do have relational databases here, but we also support non-relational databases like Mongo, or even object stores like S3.
Oh, very good, very good. Well, just as a reminder to everybody that today's webinar has been recorded, so if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email link to access the webinar on demand. The webinar will also be available on securityboulevard.com. Just look in the on-demand section in the webinars page, and it should be there. Our 4 Amazon gift card winners today are Michael Y. Congratulations, Michael. Steve
Woohoo!
W.
Well done, Michael.
Congratulations, Steve. Ed R. And finally, Andrew L. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Rob, thank you very much for taking the time to put this presentation together. It was really good, very comprehensive. We all appreciate it.
Most definitely. This was so much fun getting to share it with you. If you'd like to learn more, hit me up on Twitter at Rob_Rich or email us at info@cyril.com.
Excellent. And finally, I'd like to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Be well.
Thanks, everyone.